So that means instead of using a linear regression, we are going to actually find the slope, and the slope of the women is going to be 85.4 minus 35.7. Okay? And, oh, I'm sorry, I've got to use this particular one. So the slope's going to be 58.9 minus 35.7 over 40 minus 0. The slope for the men is going to be 75 minus 85.4 over 40 minus 0. The men's slope is going to be negative. The women's slope is going to be positive, which does say what our graph says. This is the y-intercept. So if I look at the women, I'm going to have plus 35.7, and if I look at the men, I'm going to have 85.4. And now basically what I need is to find out what those slopes are. So we take our calculator, and we're going to do exactly what it says here. We're going to say 58.9 minus 35.7 divided by 40 gives me a slope of 0.58. Now we'll do the same thing with the men. 75 minus 85.4 gives me this number divided by 40 is a negative 0.26. Negative 0.26. That's what you get for number 15. So now you found the two equations. We got the men's and we got the women's. So I'll separate it so you know the difference. On 16, they're asking us to, if the percentages continue to follow linear models you found, what will the employment percentage for women and for men be in 2005? Now keep in mind, in 2005, that would be x equals 55 years. And I would actually take this and plug in 55 and find out what the percentage is going to be. I would do the same thing for the men, 0.26, 55 years, plus 85.4. And when I do that, I'm going to get an actual number. Let's see if I can move this up. So I come along here and I'm going to go 0.58 times 55 plus 35.7. And I get 67.6. So 67.6% of the women will be in the workforce in 2005. Now if I do the same thing with the men, negative 0.26 times 55 plus 85.4 says that 71.1% of the men will be in the civilian workforce. All right, so now number 17 says, when will those be the same? Well, if you really want to know when they're going to be the same, we need to know when they intersect. So let's let our graphing calculator do this. I'm going to actually put in 0.58x plus 35.7. And on the men, I'm going to put negative 0.26x plus 85.4. And I'm going to graph it and see how it looks. So there's the women's, there's the men's, and we need to know where they intersect. Obviously my window's not big enough, so I go to the window button. What I'm going to do is put window, and my X max is at 49.5, and I just said 55 years, so I'm going to say 60, and let's see what it looks like. And we want to be able to see where those two intersect. Where they intersect is my answer. Ooh, very close. I will see if I can find it. Second, calc, intersect. There's my first curve, there's my second curve, and then it should move to the intersection point, which says in about 59 1/3 years. So if I look at number 17, 59 years from 1955 is going to be in the year 2014. So that's when it will be about the same, and it looks like that percentage will be 70%. So 70% of each of them, and we're pretty close here, will be in the workforce. Now number 18 basically says, how come we can't use this indefinitely? And many of you are making it harder than what it is, but if you think about it, linear means that this graph should keep growing. Well, the problem is you can never have more than 100% of the women in the workforce, and you can never have less than 0% of the men in the workforce. So basically for number 18 is you can't go above 100% for women and you can't go below 0 for the men.